What's going on, everybody? Welcome back to my YouTube channel. Look at this nice and beautiful question on the board that we're going to be solving. And the question says, find the values of x for which 1 over x all raised to the power of 2 minus 1 over x all raised to the power of 3 is equal to 80. Our first step will be for us to introduce substitution, as in say, let 1 over x, which is 1 over x, be equal to a. That means wherever I see 1 over x, I'm going to be putting a there. So this first term now becomes a raised to the power of 2 minus the second term becomes a raised to the power of 3, and this is equal to 80. Now our next step will be for us to split 80 into 2 such that one of the term of 80 would be a perfect square and the other would be a perfect cube. So we have a squared minus a cube. This is equal to, now splitting 80, we have 16, which is a perfect square, plus 64, which is a perfect cube. So 16 plus 64 gives 80. So we have a squared minus a cube. This is equal to, since 16 is a perfect square, that means it can be written as 4 squared. Plus, since 64 is a perfect cube, that means it can be written as 4 cube. Very good. Now, our next step will be for us to move the terms on the right-hand side to the left-hand side. So on the left, we have a squared minus a cube. As 4 squared crosses to the left, it becomes minus 4 squared. And as 4 cube crosses to the left, it becomes minus 4 cube. And this is equal to 0. Now, our next step will be for us to group the terms. We're going to be grouping the terms with square together and the terms with cubes together. So let's group the terms with square together. We have a squared and we have minus 4 squared. So minus 4 squared. Now group the terms with cube together. This is negative a cube. So negative a cube. And this is negative 4 cube. So negative 4 cube. This is equal to 0. So we have a squared minus 4 squared. Now notice that negative is common here. So I'm going to be factoring out negative. Now open a bracket. Since I factor out negative, I'll have a cube. Now I'll be having plus here, because when negative is multiplied by positive, you get back negative. So 4 cube, so 4 cube. This is equal to 0. So we have two properties. We have the difference of two squares and we have the sum of two cubes. So for a property of difference of two squares, we have, for example, when I have x squared minus y squared, this is the same as x minus y times x plus y. So this is a property of difference of two squares. Then what about the sum of two cubes? For sum of two cubes, let's say when I have x cubed plus y cubed, this is the same as x plus y times x squared minus xy plus y squared. So we're going to be applying these properties to what we have here. Now let's apply the property. Well, if you notice, our x is in the form of a and our y is in the form of 4. So let's apply the difference of two squares. So we have x minus y. Our x is a minus y. Y is 4 times x plus y times x plus y. X is a plus y is 4. Very good. Minus the same thing. This is sum of two cubes. Remember, our x is a and our y is 4. So we have x plus y, which is a plus 4 times x squared, which is a squared, minus xy. So minus xy means a times 4, which gives 4a. And then plus y squared. Y squared is 4 squared, which is 16. So plus 16. And this is equal to 0. Now notice that a plus 4 is actually common. So we can factor out a plus 4. So factor out a plus 4. So a plus 4 is actually factored out. So a minus 4 times a plus 4 divided by a plus 4. We're going to be having a minus 4. So a minus 4 minus. Now a plus 4 times a squared minus 4a plus 16 divide by a plus 4. We have this expression, which is a squared minus 4a plus 16. Good. And this is equal to 0. Now our next step will be for us to use this negative to open up the bracket. So we have a plus 4 times, we have a minus 4. Now using this negative to open up the bracket, we're going to have minus a squared. Now minus times minus is plus 4a. Now minus times plus is minus 16. And this is equal to 0. Now let's simplify what we have here. So we have a plus 4. So a plus 4 times. Now this is minus a squared. So I'm going to be writing minus a squared. And this is a plus 4a, which gives 5a. So this is plus 5a. All right. And minus 4 minus 16 is minus 20. And this is equal to 0. So we have two cases. We have for case 1, let me write case 1 here. We have a plus 4 to be equal to 0. And then for case 2, we have negative a squared plus 5a minus 20 to be equal to 0. So we're going to be solving these cases one after the other. So for the first case, so I'm going to write for case 1. For case 1, to get the value of a from case 1, I'm just going to move 4 to the right hand side so that we have a to be equal to negative 4. So this is one value of a. Now let's get to the other values of a by going to case 2. Now for case 2, so for case 2, remember we have case 2 to be negative a squared plus 5a minus 20 to be equal to 0. Now I want to get rid of this negative. So by multiplying through by negative 1, so negative 1 times negative a squared gives a squared. Negative 1 times 5a gives negative 5a. Negative 1 times negative 20 gives plus 20. And this is equal to negative 1 times 0 is 0. So I've been able to get rid of this negative by multiplying through by negative 1. Now we have a quadratic equation. And we're going to be using the quadratic formula to solve this since we cannot factorize. So from this quadratic equation, our a is the coefficient of a squared, which is 1. Our b is the coefficient of a, and that is negative 5, so negative 5. Then our c is the constant term, which is 20. So I'm looking for a. A, using the quadratic formula, is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now let's substitute into this quadratic formula. So we have a to be equal to, this is negative b, so negative b is negative 5, so negative 5 plus or minus the square root of b squared, so that's negative 5, this is b squared, minus 4 times a times c, so 4 times a is 1, times c is 20, all over 2 times a, that is 2 times 1. Very good. So we have a to be equal to negative times negative 5, we have positive 5 plus or minus the square root of, now negative 5 squared is actually 25, minus 4 times 1 times 20 is 80, all over 2 times 1 is 2. So a now becomes 5 plus or minus the square root of, now 25 minus 80 is negative 55, all over 2. Very good. So now we can be able to split this negative 55 so that we have a to be equal to 5 plus or minus the square root of, negative 55 is the same as negative 1 times 55, all over 2. Simplifying further, we know that whenever we have, for example, the square root of a times b, this is the same as the square root of a times the square root of b. So let's apply this to what we have here. So that a becomes 5 plus or minus. Here I'm going to be having the square root of negative 1 times the square root of 55 according to this property, all over 2. Very good. So a now becomes 5 plus or minus the square root of negative 1 is iota times the square root of 55, so that is iota root 55 all over 2. So there are actually two values of a here. We have a to be 5, go with a positive, plus I root 55 all over 2, or a is equal to 5. Now this time, go with the negative, minus I root 55 all over 2. Very good. So there are actually three values of a that we've got. Remember, one of them is equal to negative 5. So these are the three values of a that we've got. Now recall that we're not just looking for a. So recall that the question said we had to look for x. And we substituted by saying let 1 over x be equal to a. So we're going to be substituting each of these values we've got. Starting with the first value of a that we've got, let's say when a is equal to -5. So I'm going to be putting -5 here. So we have 1 over 1 over x to be equal to the value of a we've got is -5. So let's put it there. And to get the value of x from here, we take the inverse of both sides. So the inverse of 1 over x is x. This is equal to the inverse of -5 is 1 all over -5. And this is the same as -1 all over 5. So this is one value of x, which is a real solution. Now, this time, let's say when a is equal to, let's take this first value, is equal to 5 plus I root 55 all over 2. So we're going to be substituting this value of a here in order for us to get the value of x. So we have 1 all over x to be equal to the value of a we are substituting is 5 plus I root 55 all over 2. Now, in order to get the value of x, we have to take the inverse of both sides. So the inverse of 1 over x is x. This is equal to the inverse of 5 plus I root 55 all over 2 is flipping the positions. The denominator becomes the numerator, and then the numerator now becomes the denominator. 5 plus I root 55. Very good. Now we can't just stop here because we have a surd as the denominator. So because of the surd happening on the denominator, we're going to rationalize. So how do we rationalize? We're going to be using the conjugate to do that. So I'll take this expression and multiply by the conjugate. We have the conjugate to be 5, conjugate of the denominator, 5 minus, so instead of plus we use minus, I root 55 all over, all over. Now, the same thing, 5 minus I root 55. Very good. So we actually rationalize using the conjugate of the denominator. The conjugate actually means the opposite sign that we have. Very good. So now x now becomes 2 times what I have here, which is 2 times 5, that's 25, minus 2 times I root 55. So instead of me to do it that way, I'm going to be writing it just like that. So 2 times this expression, which is 5 minus I root 55. That's it. It's actually good like this. All over. The denominator is in the form of x plus y times x minus y. Look at it. 5 plus I root 55 times 5 minus I root 55. And actually, this property is a property of difference of two squares. So that means I can write this in the form of difference of two squares. So which is 5 squared minus this expression, which is I root 55 squared. Very good. So this simplifies into x equal to 2 times 5 minus I times the square root of 55 all over 5 squared is 25 minus, well, this expression is same as I squared times the square root of 55 squared. Very good. And we all know that I squared is equal to -1. Very, very important. So that means x now becomes 2 times 5 minus I root 55 all over, we have 25 here, minus, remember this is -1, so I'm going to be putting -1 there, times, now watch, this square can cancel off the square roots, leaving behind 55. So x becomes 2 times 5 minus I root 55 all over. Now this is 25. Now watch. Minus, okay, let me just put a negative here. -1 times 55 is -55, right? Very good. And this becomes x equal to 2 times 5 minus I root 55 all over. This is 25, and this is negative times negative. So when negative multiplies negative, it becomes positive. So we have 25 plus 55. Very good. So x now becomes 2 times 5 minus I root 55 all over. Now 25 plus 55 is 80. Very good. Now 2 here, 1. 2 here is 40, making the final value of x to be 5 minus I root 55 all over 40. Very good. So we've got two values of x. Now to get the last value of x, I'm not going to do that, but I'm going to be giving you as an assignment or homework. Let's take it as homework. This is when a is equal to 5 minus I root 55 all over 2. So I want you to substitute this value of a into our normal substitution of 1 over x equal to a, and tell me the result in a comment section. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.